Hey, hi everyone. Welcome back to the Saksham Vedi channel once again. And in the last video, we discussed about a lot of things about system design. And this is Sunday today. And I hope, oh, maybe it's not Sunday today when you're watching the video, but happy Sunday. So let's start the learning. So we are learning here in this video is coordination in distribution system. So first understand what is coordination. First understand what is coordination. What actually we meant by coordination. So suppose you have three people and you have to you have a stone with stone name X. You told him this is X. You ho- then he told him that it is X. Then he told another person that it is actually a X. But if you told him X, but he understood it to Y, but and he told him to Y, then it is lost. He told then this X become what? Then X become what? Y. So here what we saw, the coordination is important. Coordination means the way in which we handle the things with different people to coordinate the data and things when we have a different people involved in that process is called coordination. And what is distributed system? I already explained to you. When we have a multiple servers, multiple dbs, and they are connected to each other and they are continuously interacting, it's called distributed system. Okay, now in this coordination, there are 4 points that we need to know. These 4 points are mandatory to learn, and like you just these 4 points are necessary to understand the whole system design in future that we learn. Okay, so the first is leader election. Okay, so the first is leader election. So what is leader election actually? So what is leader election? So suppose you have nodes. Okay, you have nodes. Sorry, database. You have suppose db1, db2, db3, db4, db5, and db6. Now you said okay, I take 100 rupees from my account and now I have 900. Now what happened in db3? Suppose it's updated, db5 is updated, db1 is updated. Now in all these dbs we have our you can say like 900, 900, 900. But in this db2, db4, and db6 still 1000 rupees balance is showing. So it causes a lot of problem. If you call your data from db6, it will serve your stale data and you are saying wow, and I just withdraw 100 rupees from my account and still 1000 rupees, which it's amazing bank. So here it's a bank loss and all of the thing happened, and it's might be l- cause a lot of problem to you also. So this is the cause of the main you can say in this place we have to think about a leader. Okay, and that and the other servers or other db just follow the leader. That's why we have a process of leader election. So let's understand the concept of leader election first. So suppose we have a dbs, db1 to dbn. Then all these node we have a leader which is suppose db1. Then all of the nodes just follow this db2 to dbn. Just all of the nodes just follow this db1 follow on db1 thing. Suppose db1 says write 100, then they write 100, otherwise they are not. So they just the replica of these db, and this is the main db where the write operation occur, and they ask continuously the data from their leader db. They do not write on their own, they are dependent on their live leader db. So this is a consistency we maintained. Okay, so you understand this particular leader election. We have a leader node and all of the followers. Now let's go to the distributed locks. Distributed locks is also a good concept because it increase our server performance. So suppose we have four servers, S1, S2, S3, and S4. Now you have a cron job at that is scheduled at like 12 a.m. at night, okay, and it's have to do like fetch the data from server and to display all the your t-shirts, all the all the new t-shirts to the servers from the servers. Okay, okay, it fetch all the your account balance. Okay, let's suppose it's just fetch the account balance, okay, and ping the message to the mail. This is the job. So suppose this is HDFC Bank, server 1, server 2, server 3, server 4. Now what happened when the cron jobs start? All the servers now get the request S1, S2, S3, S4. So what will happen? All of them will start processing the same request P0, P0, P0 means processing the payment gateway, initiate the payment gateway, and and send the email. So you will receive four emails now, not one. So it's kind of annoying. And we saw a lot of scenes in the government scenarios when we ping a message and okay, let's wait. It might take a while. Then after few days after, they are pinging a lot message because the queue is stuck. The queue is stuck, and when the queue is free, then the particular they are like they are throwing all the messages one by one, and that is quite annoying and irritating. That's the thing behind the scene. Okay, it's a lot. It's we can discuss that thing later, but yeah. So here if you understand this server S1 to S2 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 4, and they are cron jobs, and this particular thing is this scenario is just simple scenario. You have a four workers and you have to assign a task to four workers. So then if all the four workers doing the same task, then it's like quite overwhelming for you. So it's not needed actually. So what we can do, we create a lock. Okay, we create a lock. So what it is say S1, S2, S3, S4. When suppose a task came, when suppose when suppose a task came, when suppose a task came, okay, when suppose a task came. So the server one, suppose it go to the server one, the server one acquires the lock with some ID. Okay, suppose it's ID 1 or something. Then if server 2 have to do this task, then it have to first acquire this lock, and then it have to perform. But the lock deny it. Okay, you have this ID, no, you cannot able to perform this task. So that's why server 2 is not able to perform this task. So here we have the concept of server lock, means a server can do only one task a time. And suppose we have a multiple server doing, so they do not able to do same task multiple server at the same time. Got my point? Next we have a consensus is very important topic as well, because it is very important. First you have to understand one thing. Suppose these are the peoples. I know they are not looking like peoples, but they are peoples, and we have a voting happening. Okay, and what happened that suppose everyone's saying that okay, uh, I have 100 rupees, I have 200 rupees, I have 100 rupees, I have 200 rupees, and I have 300 rupees. So if you see, every server have a different data. Every server have a different data. So And if you ask or query any data from these server, there is a high possibility you get a different data from different server. Suppose you would get 100, would get 200. So is it good thing? Is it good thing for your own server, for sorry, for your own ID, for your own data? You have a different data. Even you do not have the information. Okay, might we have 100 rupees, might we have 200 rupees, might we have 300 rupees, but it's not a good idea. It disrupt the whole concept consistency here. So what we have to do, we have consensus algorithm. What it says, all the nodes, all the nodes must have to agree at some time. So this is called consensus. Suppose we have 100 rupees, we have 200 rupees, we have 100 rupees. Okay. So if you see, we have a two node which have 100 rupees, and there is only one node which is saying 200 rupees. Then this node should agree. Okay, I am wrong. I am corrupted. I have stale data. I must have to make sure that I have only 100 rupees. So it update himself to 100 rupees. So this is consensus. Like every node must have to mutually agree or commit before performing the action, and 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 they have to be consistent. They have to maintain consistency. So this is called consensus. Then is service discovery. Service discovery is same as the like registering a DNS. Next is service discovery. So the service discovery is same as service. So service discovery is same as the concept of DNS and all the thing, but like it. I will explain you a little more better way. So okay. So suppose we have a different servers, server 1, server 2, server 3, server 4. Server 1, server 2, server 3. You know this thing, when any new IP, when we change the internet, when we change the network, when we change the devices, the IP address change. And in on when where all the network communication is going on, from IP addresses. IP addresses, from all the network communication is going on from IP address, MAC address, and all that. So when any server change, restart, or new server came up, it registered himself to in a directory which is called registry directory. It registered himself into that and says, oh, my new version, and this is my new IP, you can just update it. So now the network call rerouting at the same moment. So it's kind of service discovery, like it continuously sending a request to sending a health request to the registry services and saying, this is my new IP, this is my new IP, this is my new IP, this is my new IP. And the service registry is continuously updating to all the network calls. Okay, S1 you have to go to S2 with this particular IP. So on that way the service discovery is happening, means how you discover the server over all of your network zone, over all of your distributed system. So here we understand the concept of leader election, in which we have to select the leader of all the nodes of all the server, where each server have to follow their leaders. Distributed locks means um, distributed locks means a server can do a task only for a specific. It is not that all the server are doing a same specific task. So we have some kind of lock, key and lock mechanism. So our server is locked for one task. Consensus, not task, process, anything you can say. Consensus is like every server must have to mutually agree on the data we have. Server discovery is like discovering the servers and their IP and all that. So it's like basic server discovery. So these are the four major part when you are describing and defining the distributed system, and I hope you love it. And if you have any doubt, feel free to comment me, and you can follow me on LinkedIn and ask your doubt on LinkedIn as well. And thanks you. Bye bye.